Hello and welcome to K8sKoach. I'm Tom McGonigal and I'm your host of K8sKoach. And today I have with me Philip Griffiths, who's a kind of a new friend and a new colleague. And he is, Philip, would you mind introducing yourself, please?
Yeah, sure. Hi everyone. So Philip from Cambridge in the UK. I read recently that the In-Betweeners has recently become big in the US. I don't know if you and your audience come across it. It's like a comedy from the teens. And I was reminded of it because in that program there's a very iconic scene with like friends, and yeah, it literally reminded me of that as you were.
Does it take place in Cambridge, or was it just a friend comment?
It takes place. It's like some fictional place in the UK, like kind of an hour from London. It's about a boy who switches from being in a private school into a state school because his parents get divorced, and so he gets mercifully bullied and falls into this crowd of they call it in-betweeners. So like people that they're not the least popular, but they're not the most popular. They're the in-betweeners.
I consider myself a high school in-betweener.
Yeah.
I wasn't the most popular. I didn't have a girlfriend, right? So I was kind of in between. The most and the least popular kids. That's a great title. Well, thanks for the tip. I actually believe I have heard of it. I'm gonna re-look at it. You probably wouldn't know which streaming service in the U.S. has it. Do you know?
I do not, but I'm sure the internet has it.
Yeah, I'll find it. So I'm watching some really tremendous shows, and so the one that I'm really most excited about is The Penguin. Do you guys get that in the UK?
No, I don't know The Penguin. Oh, is it like Batman related?
Yeah, it's Batman. Yeah, so the most recent Batman, Colin Farrell, the Irish guy, played him, and he wore like a prosthetic suit, and they've turned it into like a crime. It's like Sopranos, it's like or Breaking Bad. It's this tremendous TV show, and it's on in the U.S. And the reason I brought it up, Philip, is I'm going to ask you what I ask all of my guests: is what Batman is a superhero, and so what is your leadership superpower? Do you have one?
I don't know if I'd necessarily go as far as leadership superpower, but I like to think of myself as a generalist. I know a little about a lot of things, and so while I come from a non-technical background, I can get really mean with a PowerPoint and a whiteboard, and kind of convey technical things to non-technical people and non-technical things to technical people. I like to think I'm an in-betweener.
A technical in-betweener. Oh, that's great. And by the way, that would be a great like superhero name, the In-Between Man or something. I appreciate that. That's really quite good. Thank you. Now I know we connected over Net Foundry, and I was when about a year ago I was very interested in Zero Trust, and I was very impressed by Net Foundry's OpenZITI project and so forth. And would you mind kind of articulating what's going on with Net Foundry and OpenZITI and Zero Trust?
Yeah, and specifically, I came across your I think it was Zero Trust Krav Maga. And the ideas you're articulating there, and I thought, here's someone that appreciates security by default, and that's what our intention is at Net Foundry. Long story short, we believe I hate the term, but the digital transformation, the switch from a analog society, a manual society, into everything being application and digitally driven, which has been taking place for many years and is still many decades to go, particularly as you look at like OT and cyber physical systems. And so as we're going through that transformation, we have digital systems and they need to be connected, but networking is inherently insecure by default. And so Zero Trust posits treat the network as compromised and hostile, least privilege, zero trust. But yet, most networking is seen as an afterthought. Developers don't think about networking. It's only when it goes to production, and very late in production, people are like, whoa, we've got to do some networking around this. And in addition, most of those technologies, in fact, I say most, pretty much all of those technologies, listen on the network interface. And so they have implicit trust in the network. They have implicit trust that someone's not going to try to attack from the network. And that's fine until your firewall, your VPN, whatever's at the edge, has a 0-day, or a someone wants to DDoS attack it, or do a credential stuffing attack, or an MFA bypass attack, or whatever the attack may be, it's a an attack across the network. And so our thought process was, we need private networking because that can stop those attacks, but everything needs to be application driven. So what we need is software driven private networking. And so that's what we set out to create. And the only way to do that truly properly, in our opinion, was to open source it. So we created the OpenZITI project, which in a nutshell is an overlay network which can be embedded into the application or embedded into a product, or deployed on host, like a let's say a better VPN, but to really imbibe those principles of zero trust and deny by default, so that we can flip the asymmetry of risk in favor of the defenders, and to do this all within a way which is very software driven, highly automated, so that instead of deploying VPNs, SD-WANs, jump servers, layer 4 load balancers, public DNS, IP whitelisting, ACLs, all that stuff, we can just inherently build it into the product. That was very much our goal.
Oh, that's marvelous. That was a great explanation. Just in terms of this kind of listenership, are there any hooks into Kubernetes with OpenZITI? Or
Definitely. Three come to mind. Number one is the simplistic one of, hey, I'm deploying my Kubernetes and I need it to connect somewhere else. It might be to another Kubernetes cluster running in another cloud or on premise. It may be connecting to non-Kubernetes resources. It may be a user who's trying to access the application. So in that scenario, you can use our technology and make it incredibly easy to connect. In fact, I once, it's not a superpower, it's magical. I wrote a blog comparing zero trust using Harry Potter analogies. And
I remember that. Yeah, that
yeah,
was marvelous. Yeah.
very much goes into the idea of, you can make your resources invisible. And so, in fact, actually, just yesterday, I did a post on LinkedIn around it was some Kubernetes exploit across the network with no authentication. To which I said, make your Kubernetes cluster invisible. Make it so that even if there's an exploit inside your Kubernetes API or the part of the Kubernetes system, it can't be exploited from the network. But then the other part of the blog that I wrote was make it invisible. And then number two, magically move packets from point A to point B, like having a port key, assuming some of your listenership is familiar with Harry Potter, in that you don't have to manage and configure any of the networks in between. It just magically happens. And so that's use case one. How do I connect a distributed Kubernetes system? How do I connect external systems? Use case two is how you could embed our technology directly into the applications themselves before they then get deployed onto Kubernetes. In our opinion, application embedded is very much the North Star. Not everyone can do it, but if you can do it, it makes you more secure. It means your application has no listening port, even on the Kubernetes network, not even onto the underlying host network. So you can't be attacked from the underlying network. You can't be attacked by IP. You can't do a port scan and find it because it's just not there. It's invisible. And then in addition, it provides the best user experience because you're not having to deploy those additional agents. It's literally inside the application runtime running in memory as part of that binary. The third one, I was listening to a podcast the other day and it was talking about how Kubernetes networking works. And I mean, this is a very long-term vision for me, but I thought, wouldn't it be nice if our technology was like just directly embedded inside Kubernetes so that you could deploy your nodes, your clusters, your pods anywhere, and it just worked, it interconnected and was secure by default without having to worry about that traditional networking infrastructure that you normally bolt on. But that last one's a very visionary one.
Yeah, the one that I think I want to tease out some more is the second use case, right? You have this so OpenZITI project. I open up the page, supports many different SDKs. So it includes a ZD SDK for C, a ZD SDK for Golang, a ZD SDK for the JVM, a ZD SDK for Pi, a ZD SDK for Swift, a ZD SDK for Node.js, and a ZD SDK for C#. And so what that gives you is the ability to write your app, right? What you're running inside the pods, right? And it leverages the OpenZITI fabric and the network to communicate and to to secure and create that zero trust for your individual app. And I believe, stop me if I'm wrong, but that's a very big differentiator with the OpenZITI project, isn't it? It's the SDKs, right?
100%. And this is probably a horrible marketing term, but effectively it gives you that ability to develop once, run anywhere, connect to anything.
Mm-hmm.
With the really inheriting some of the ideas that you have in Kubernetes, because in Kubernetes and namespace, if you're inside your cluster, you can just privately connect to anything. But as soon as you go outside that cluster, now you need to worry about DNS and IPs and blah, blah, blah. If the system's on ZT, you don't worry about that. You can connect to anything, and effectively you get a private DNS extending to anywhere and everywhere. So it doesn't matter if you move the workload, if you shift it, spin up, spin it down. We make it incredibly easy and securely to interconnect those distributed systems. And so from my perspective, I like to think of ZT as being of making it quicker and easier to develop secure by default distributed applications. The SDKs also enable you to go into very constrained systems. So in fact, this week I was talking to an industrial company and they were like, could we deploy this onto our PLC? And of course, the PLC is not going to run Kubernetes. It's literally got megabits of RAM and CPU. And I was like, yeah, sure. The CSDK is 2 meg of RAM and 8 of disk. And so you could run on something like an ESP32 or very constrained systems. This is one of the we do a lot of work in military as well, and they may have, let's call them, one-way delivery systems or drones which need to connect into these systems. And so it really gives you the ability to bring private secure connectivity into both the software development lifecycle to have the highest level of security and not trust the network, but also to really go anywhere and everywhere in a way that is unique. And if you can't change your application, if you can't embed an SDK into it, no worries. We've got loads of non-embedded versions to help that journey, because at the end of the day, zero trust is a journey.
So, two things that are really coming up very strongly for me is, the comparison to like a traditional service mesh inside your cluster, right? But, the limitation there is you don't have that ability to connect up to the fabric, the ZD fabric, and have it across Kubernetes clusters or across application environments or data center, and so that's really one of the kind of specific things. So I'm thinking of it, and forgive me if it's an incorrect way to think of it, but I'm thinking of it as like this internal or this macro service mesh, right? It's just a bit, but there's also the kind of the zero trust aspects of where you're not trusting, things, and there is an authentication element and so forth,
For sure. And I want to be clear, I'm not a service mesh expert. So if anything that comes out of my mouth is incorrect, please, people, hit me up and give me some feedback to corrections. As you allude to, OpenZITI is not a service mesh. If you squint, it's sort of, you're like, there's some parts of service mesh in there. Some major differentiations just off the top of my head is, traditionally service mesh focuses on the layer 7, whereas we're focusing on layer 3, 4, 5 in the OSI stack. I'll say more 4. So a little bit more comparable to something like Istio Ambient in that way. But then, as you also allude to, service mesh really started off on the east-west aspect, and some people are like, well, we could do some north-south, but then you tend to see people using WireGuard and VPNs to bridge those connections. OpenZITI technology can do east-west, it can do north-south. It's really designed to go anywhere, and because our initial aspect was we know we need to be able to do that north-south part, we built a smart routing private fabric to be able to bridge all those connections and abstract away a lot of complexity that you'd normally see from connecting distributed systems, so that you can deliver both the private connections, but also ensure it's performant and reliable across that distributed system with lots of, health monitoring and end-to-end metrics to be able to make that incredibly simple to do. You then have the differentiations from, again, from my knowledge, most service meshes start off as open by default and kind of do some aspects of zero trust. Personally, when people talk about zero trust and they start talking about IP addresses, I'm like, you're trusting the network there. For me, doing least privilege, doing deny by default, service-based connections rather than host-based connections. That requires strong identity. That requires really a intent to start with zero trust. As I said on LinkedIn a few times, mutual TLS does not equal zero trust. It's just a better link. There are way more things that you need to
agreed.
Have a proper zero trust network. And so I know some organizations that say to me, oh yeah, I'm using OpenZITI or NetFoundry for my north-south connectivity, and I'm using Istio, or I'm using Calico, or I'm using Cilium for my east to west within my clusters. I've spoken to some other people who have said, why would I need a service mesh? I'm just connecting everything over OpenZITI, and that for them that works. I think there is a better together. And it's an interesting area to explore as we go forward.
Well, you mentioned it a moment ago. Just the identity is better, right? And so could you talk us through that? Because that's a critical piece of zero trust for me, right? And I'm gonna like summarize the way I think of it. Like every app, every device, every component of the network is identifying itself, and there's an authentication component of zero trust. Would you agree with that kind of explanation, or?
100%. Again, our starting point was from a zero trust networking perspective, but it was, we cannot trust the network. Therefore, why the heck would we trust IP addresses? Therefore, anything that exists on the overlay should have its own identity. And so we built PKI into OpenZITI. And if you want to exist on the overlay, let alone access anything, you have to go through a process of bootstrapping trust. And that can be from our identity system, though you can bring your own external provider as long as it's JWT X509 or very soon OICD compliant. And so, in fact, we've got some wonderful YouTubes and blogs which talk, for example, of making a dark API using OpenZITI and Spiffy Spire, so that Spiffy or Spire is providing an identity to the applications, to the APIs, and then we're using that identity system to replace the one that we would normally provide, because we've built the system to be interoperable with those external providers, either replacing the primary authentication or adding additional secondary authentication on top. In our opinion, this is really crucial because it enables us to start with a strong identity rather than try and bolt it on afterwards. But it also enables us to abstract away a lot of underlying complexity. For example, when you use our system, you get a private DNS so that you can send. I could, for example, have an endpoint called Thomas McGonigal, and I can have an endpoint called Philip.Griffiths, and I say send packets from here to here. And in fact, if you're just completely on the ZT overlay, you don't need to know what my IP address is. In fact, I don't have an IP address. My underlying infrastructure might have an IP address, and OpenZITI understands how that will work, so it can shuffle packets between our endpoints and our identities. This enables us to abstract away a lot of complexity. It enables us to start on that deny by default model. It ensures that we are doing authentication before you can even exist on the overlay, with additional authorizations and posture checks to make sure, for example, your device is secure, or you've done a TOTP MFA, or other such things which you can layer on top. The starting point is definitely, in our opinion, having strong cryptographic identity, because as much as it is slightly a misnomer, there is some trust somewhere. We've built a system that tries to reduce as much of that implicit trust as possible, but you need some trust. And so having identity systems is core to that. It also ensures that, for example, we can provide end-to-end encryption, which you could call it zero knowledge, you could call it sovereign identities. Effectively, only the source and the destination endpoints, your applications running on a pod or a cluster, can decrypt because they have the private keys. Nothing in the middle, even the data plane or the person, the organization hosting the data plane, they cannot decrypt it because it is a direct trust relationship between this pod and that pod, even though they're on different sides of the world, in different data centers. So really having that design perspective of how do we reduce implicit trust in the system, in the operators. So it's really the application owners who are able to ensure their applications can securely connect and not be man in the middle or manipulated in some way.
Now, when we were talking before, you were talking about really some interesting edge use cases. You were talking about drones, these kind of one-way comm for drones, or those particular motherboards that you were describing, those platforms that you were describing that had very
Mm.
little RAM and so forth. Yeah, I have to say, I think the OpenZITI or Zero Trust market is just ripe to take over. All of the edge, comm. It's just so. I think that's one of the most exciting things about it. We were just discussing about identity. I also find incredibly exciting and interesting about OpenCD and Zero Trust. But it's the market opportunity. It's like why wouldn't every wireless access point on like a college campus have like a management interface using something like OpenZD? So that all that comm and all that communication and configuration would be, you wouldn't need like a management LAN, right? You could just do it across
Yeah,
the
for sure.
wireless, right?
So
Yeah.
in fact, one of the public adopters of OpenZT is a company called Chirp, and Chirp provide it's like distributed wireless capabilities using blockchain, and so you can contribute some sort of I think you buy a box, you contribute, people being able to access services, and then you earn coins from doing it. And all of the connectivity between those boxes that people deploy in their houses or deploy in their shops to the back-end infrastructure is across OpenZT, because it makes it crazy simple to bridge those connections, even if people have NAT or double NAT or
Right.
thing. They just set up the box and boom, it's immediately connected and automatically done. In fact, if I honestly take a step back, the majority of use cases I know for using OpenZT and NetFoundry together with Kubernetes has edge-based deployments. Where another organization we work with is one called Marpos. They provide precision measurement instrumentation, which they then they ship to people that are building cars or they're building factories, and they're building stuff that has to be really, really precise in the production process. And they switched from, hey, we're shipping a piece of hardware, to we're shipping digital services. And so to deliver those digital services on their product, they use K3s because that's the easiest and quickest way to get started. But then all of those edges need to connect back to their cloud, their customer's cloud, to remote engineers. And they could have used a VPN, but now you've got the pain of managing at scale. And in their words, it's a backdoor to their customer's network, because effectively you're saying, my network trusts your network, I'm just going to bridge them together. And they're
Right.
like, no, our customers don't like that. We want to make sure our applications running on K3s, they can only connect to our cloud and nothing else. That gives way more assurance to their customers. Another one that I know of is there's an organization called Ubitech. They've built this capability called Maestro. It's effectively like 5G orchestration. They do a lot of work with the European Union research around EU Horizon, etc. And we're working on some projects where those 5G cores and nodes that run Kubernetes at the edge, maybe K3s, maybe K8s, it's all being interconnected across OpenZT, because it makes it wildly simple to securely connect these distributed systems. And so, when I'm looking to talk to people and explain the value, it's really that distribution piece, it's needing a security piece. And then probably third of all is that we've actually built our technology for the product providers, where they can actually build it into their products rather than their customers bolting on after the fact. Jen Eastley of CISA recently came out, and I mean, she actually said some pretty wild things around how vendors were at fault for all these attacks. I won't wade into that, but there was one thing that she said that I found was very interesting, which was, we don't need more security products, we need more secure products. And that's exactly something that we try to enable, so that the Marpos, they're not delivering a security product, they're delivering a manufacturing product, which they've just made more secure and far easier to connect by building OpenZT, or the proprietary version of it, into their technology.
Oh, I love that. We don't need more security products. We need more secure products. I find that really inspiring and really, really brilliant. I love that. I've never heard that before. And who was it that said that? Do you remember?
Jen Eastley, she's the boss of CISA, so that's like that's the US agency for critical infrastructure security.
Oh, gotcha. Thank you. Now, a couple minutes back, you were talking about this Kubernetes cluster running K3s. and its need to connect back up to the cloud. And something I've learned about through you was ngrok, right? And that's like an external facing uh, like overlay network that provides X, right? And so could you articulate what that X is, and how you could use ngrok in that situation of trying to connect K3s to that cloud that the customer
Well,
has?
so, ngrok was a tool that was developed, I want to say about 10 or 15 years ago, as a way for developers to really easily be able to share, webhooks or APIs or a web page that they're developing without having to mess around with, NAT and port forwarding and VPN. They just go, oh, hey, here's a URL. Thomas, go access it and you'll be able to see stuff on my local device. It's effectively building an outbound connection to a web server, and that's dealing with all the IP and URLs to make that easy, and then you're slapping some auth on there and various different things. And so as we were developing OpenZITI, we have this concept of ZT native applications. That is, applications which are actually built on top of OpenZITI, because again, most people today don't use it as a development platform, but it actually is a development platform. You can build applications on top of it. You can build logic on top of it, which makes it easier and quicker to build secure by default applications. And so we were looking around for ideas, and we thought, what about if we built a better version of ngrok, because it's a wildly popular tool with developers? And so we built zrock as a ZT native application, because we put Z's inside everything. So it was obvious, rock, Z, there we go, zrock. And that enables you to, for example, you could have a local K3s cluster, you could have an API or a server on it, and you go, right, well, I want anyone to be able to publicly access it. So, just put a few commands in the CLI and boom, it's got a public URL so that people can access it, intermittently, or maybe it's ephemeral for forever. And for me, the really powerful demonstration of zrock was not the capability. I actually think it's super cool. Most people I've spoken to give wildly popular feedback on it if it solves a pain that you have. But I look at it from the meta level, which is ngrok was developed over 10 to 15 years. And as a company, about 2 years ago, they took on 50 million of funding. So they have a team of like 10 to 20 engineers nowadays. zrock is almost feature parity with it. Not quite, but almost. And it's been developed by one engineer. And the reason one engineer was able to do that so quickly is because he's a really damn good engineer, but B, because he built it on top of OpenZITI, he inherited loads of features and functions to build his system. And so last year, ngrok came out with some SDKs. You can effectively, they call it embedding ingress into your application. Basically, I can make this application a production level application, throw it on the internet really quickly. And so we thought, we'll do the same thing. And it didn't take us months to develop those SDKs. It took Michael Quigley, is his name, a really short amount of time. Why? Because he didn't have to write them from scratch. He just took the OpenZITI Go SDK, put a wrap around it, and that was a zrock SDK. He took the OpenZITI Python SDK and then the Node.js SDK, put wrappers around it. Now it works as zrock. And so it makes it just way quicker to build a secure by default distributed application, which in this case is making it really easy to share resources.
No, what a great explanation. And Michael Quigley, that's the fellow's name. Hats off to Michael Quigley. It's a tremendous app. Everyone should check out zrock.io. Thank you. Everyone should check out zrock.io. I just when we started first discussing it, I just did a brew search, on my Mac to see if zrock is available as a brew downloaded is, right. So the barriers to entry to using OpenZITI, are very, very low, and the capabilities.
Particularly, like if you look at OpenZITI, it's fairly complicated. Now it provides a lot of abstraction, but there's complications because it's so powerful. There's so many things that you can do with it. zrock has an abstraction layer on top of OpenZITI, which makes it wildly simple to do a few things, like share a public URL, or even share a private resource, or there's a thing called drives, which is basically like a limited version of G Drive, where you can just make files available, share them really easily. But one of the things, one of our other engineers, he just thought, you go on Reddit, you go on these places, and people are going, Tailscale and WireGuard, how amazing they are. And he thought, what if I just created a configuration file to make it really simple to do a host-to-host VPN connection? And so he spent a couple of days just writing it, and boom, it was done. He just by writing some configuration, I'm not going to say it's quite tail scale functionality, but it made it really, really easy and quick to just build host-to-host connectivity like WireGuard does. OpenZITI doesn't do host-to-host connectivity because it's focused on service connectivity, because that is a zero trust concept. Host-to-host connectivity on by default is not a zero trust concept. But the point is, Xerox provides an abstraction layer to build more, let's call them point solutions. I just want to be able to do this one simple use case. I can write one line and that one use case is done. So yes, we have both the platform with loads of power, and we're kind of building these really simple use cases that can be enabled on top.
Yeah, it's truly marvelous, and I think the stuff that Michael was able to accomplish very easily, very quickly, is really a testament to the power of OpenZiti and what you guys have been building and what you guys have worked on. And I know you were talking about some of the abstractions, but one abstraction I was curious about was the observability into OpenZiti, with like a Kubernetes platform, or is there anything there that you can discuss?
Yeah, so I mean, today there's many options for deployment, and it basically comes down to how do you want to connect, what services are you hosting? Do you want to go on a cluster level with one of the ZT routers? Do you want to go on a pod level with a sidecar? Do you want to use a daemon set to connect into Node, or do you have an existing reverse proxy? In fact, interestingly, because we have our SDKs, we've demonstrated our technology being deployed as a module on top of a proxy. So, for example, we have an Nginx module where we took our CSDK, and so that can just sit on your Nginx load balancer ingress gateway, and that provides the termination point or ingress point onto a ZT overlay. We took our Go SDK and we did the same thing for Caddy. In fact, Xerox also has Caddy built into it. I know Caddy's wildly popular in the Kubernetes world. Some of the things that we're working on actually, can I mention these? I'll mention it once because it's coming really soon, or it's already available and just being tested, which is an admission controller, where effectively it injects a sidecar into selected pods to make a transparent proxy using the ZTDNS. But then we also have some other things which we're working on, which I'm hoping will be mentioned in KubeCon. I think it is next month. Yeah, because it's November next month, isn't it? So it's KubeCon in Colorado, I think it is.
It's Utah. Mm-hmm.
Yeah, exactly. And so we have various different options which can be done today in terms of how do I deploy, how do I connect things running my Kubernetes environment, as well as obviously as we were talking, the application embedded, or if you're outside of Kubernetes, deploying a tunneler onto the host, or we've got a clientless endpoint for users, or a whole plethora of different endpoints for the non-Kubernetes world. And then I think the beauty of our identity-based solution is that rather than, hey, I've got tons of IP addresses trying to connect to my infrastructure, and now I've got to go for a seam log and figure out what the F's going on. Now you know which identity is accessing which services at which time for how long, and no other connections are allowed because it is a deny by default system. And so you go from this huge complexity and trying to figure out the noise to, I can see exactly what is going on within my system. And then I've got health checks around it, and I've got monitoring and loads of rich information. In fact, there's an organization I know in Germany who uses OpenZiti for some Kubernetes stuff. They wrote a Helm chart to make it much easier to deploy. And they also wrote a Prometheus exporter, so you could take some of those ZT metrics and pull it into your Prometheus system to just make it easier to manage and operate at scale.
That's very helpful. Something you sparked, a question you sparked, I think it's a pretty difficult one to probably answer, but so let's say you have this OpenZiti project, and it's pretty sizable, and you have a number of endpoints, and you have a number of clusters, and this and that. What technology would you recommend for command and control and configuration management and so forth of the OpenZiti platform? So I'm imagining there being that Nginx ingress with the module being a config file, like a corresponding config file. Like, what would someone use, and can you use the OpenZT network to manage those configs, or is it more like more kind of like a traditional like networking? You push out a
can.
config.
And so when we designed OpenZT, we designed it to be fully featured and permissively licensed under Apache 2. And so it incorporates all the components you need to manage an overlay. You have the edge, the points of ingress and egress. You have the fabric, which is the control plane, the data plane. And then we also have a GUI, which sends APIs to the controller of the network that you're operating. And that works. It's functional. I know many organizations that are doing that. But if you want to manage it at scale in production, that's when I recommend NetFoundry. We have effectively built those. We've taken the open source software and we've built products that can either be delivered from the cloud, they can be completely delivered on premise, or they can be delivered hybrid, somewhere in between. With us hosting some components, customers hosting other components. That enables you to really run systems at scale, make sure you're monitoring them, you're reporting on them, you have visibility, you have integrations, you have patching systems, you have support, you have monitoring. Like our biggest customer today, I think, has 300,000 people on it. And in the last quarter, they had 100% uptime across many, many, many networks for all of those hundreds of thousands of people. That is our job. Yes, we created OpenZT and gave it away to the world for free, and we'll continue to maintain it because we really strongly believe that by doing that, we can take that paradigm shift and make systems more secure by default and flip the asymmetry in favor of defenders while making systems simpler. But at the same time, for organizations that want help, they want to run production scale, that's where we can make it wildly simple.
Wow, that's tremendous. I didn't get there in my thinking, but that makes a lot of sense. That's what NetFoundry does. I didn't realize that. That makes a lot of sense. You articulated it very well. I can totally see the value of NetFoundry and particularly with those 300,000 customers all using it. Like that sounds very complex, but like you said, that's your business. That's what you're good at. Exactly. I love that. I think I just have one last question, and I think it's kind of a softball, but where would I go to learn more about OpenZT and NetFoundry? And if I really wanted to dig in, do you have any suggestions on how to get Kung Fu at OpenZT?
So that really depends upon your choice of poison. If you prefer presentations and PowerPoints and pretty pictures which go from 50,000 feet to like 5,000 feet, then I would recommend checking out my LinkedIn or my Twitter. For example, I've done some talks at the Cloud Security Alliance where zero trust connectivity or networking for complex use cases like OT, multi-cloud, etc., military. Next week, I'm actually talking at an ICS, so Industrial Control Systems Cyber Conference in Atlanta, where again talking about these concepts, talking around how the why and the how, not the what. If people prefer to look at code and look at technical things, then I would recommend either going on the NetFoundry site or go into the OpenZT, OpenZT.io, and there's you can just start digging through either the documentation or go to the GitHub repository and start reading through the actual code, or start reading through the blogs. They're in fact, even if you just put like OpenZT Kubernetes into Google, there is a ton of content. There's like a blog we did with IBM on making multi-cloud OpenShift like wildly easy. There's some blogs from a guy called Rolando, which looks at making the Kubernetes API dark, and specifically he was using in his blog kubectl. So we took kubectl and we took the version, but we embedded these OpenZT Go SDK inside it. So effectively, you can use kubectl, as we call it, have the Kubernetes API being dark, and still be able to access it because it's accessing it over the ZT overlay, and without having the ZT desktop edge running on your device, because effectively the agent is in kubectl. And so he's got a blog on that. In fact, I think we've got a blog on that on our OpenZT website as well. And so, yeah, whatever paths you prefer, those are probably the best ones. And as people go through that, they're like, hey, I'd actually like to deploy this. the OpenZITI discourse is a really great place to come and ask questions. I've been told several times that our support that we give is like very generous. And we do that because we think it's important to build a strong community where people understand what they're doing, but then they also come help other people. So over time, it really is a self-reinforcing community for the open source.
Oh, that's terrific. I think we'll wrap it up in the next minute or two. But I know you describe yourself as kind of in between business and tech and everything. But I mean, you have such a breadth of expertise, and it's really you communicate so well. I just wanted to say how much I appreciate learning everything today, and what a great streamcast it has been. And I just thank you, sincerely, thank you very much, Philip. Was there anything you wanted to kind of advertise personally or mention personally before we close up the streamcast?
So first of all, thank you. Doing these things is always a pleasure. As you can tell, I enjoy talking, and I would merely just point to follow me on LinkedIn, looking at the Harry Potter blog, checking out some of the content. If people have any questions, feel free to ping me. I'm always open to giving help and talking more, because that's what I enjoy.
Oh, terrific. And so thank you, Philip. And I'm just going to wrap up the K8sKoach today. And thank you to everyone who's attended. And please do reach out to Philip Griffiths. It's Philip Leonard Griffiths, which is Leonard's an awesome middle name, by the way, Phil. And so it's Philip Leonard Griffiths on LinkedIn.com. And thank you for everyone who attended today and for listening to K8sKoach. If you have any feedback or questions about the subject today, just please feel free to reach out to me on LinkedIn as well. And I look forward to seeing everyone soon. And I hope you have a marvelous trip to Atlanta, Philip. And I'll see you soon. Thank you so much.
Cheers.